All right, we're going to work through the horizontal ellipse first. If you want to write on there that this one is horizontal, just so you don't get the horizontal and vertical mixed up. Horizontal, it's longer the horizontal way. So this standard form is the quantity x minus h squared over a squared plus the quantity y minus k squared over b squared equals 1. So that is the standard form of a horizontal ellipse. So for an equation of an ellipse, it always has to equal 1. So when we're writing equations of ellipses, we need to keep that in mind as well. It's always equal to 1. So really, to know the equation of ellipse, you need to know h, k, a, and b. So these formulas then would be how you can find h, k, a, and b. We'll start with the center. So the center of an ellipse is the ordered pair hk. So I have said hk is an important characteristic of every conic section. For a parabola, it's the vertex. For a circle, it's the center. For an ellipse, it's the center. So center is hk. We'll go to the, actually I'll label the major axis next. So this segment here, and it does have endpoints on the ellipse, but that segment is the major axis. So what I'm gonna label over here in the box, I'll put the major axis here. On mine, I'm gonna just highlight it so I know on my diagram that the major axis I highlighted in pink. However you want to do that on yours. But the length of the major axis, it's always 2a units long. So if you know the length of the major axis, that could be one of the ways you find your a value for an equation. But then we're going to label what's on the major axis. So the endpoints are called the vertices of the ellipse. Vertices is the plural of vertex. So there's two, we just don't say vertexes, we say vertices. So if we label, each of these has a different formula, the left one versus the right one. So I'm going to label the left vertex first. So you can label this as a vertex, and the left vertex would have the following coordinates. The x-coordinate is h minus a. The y-coordinate is k. So the reason the x-coordinate is h minus a is if you're starting at the center, you're going to the left a units. So that's why the x-coordinate is h minus a. The k value is the same because they're on the same horizontal line. The rightmost vertex then has the following coordinates. X-coordinate is h plus a because you're going to the right a units, and the y-coordinate is k. So the distance, this is something we'll talk about as we're writing equations. The distance from the center to a vertex, that is a distance of a. So this a that's right here is representing the distance from the center to a vertex. And that's why from a vertex to another vertex, that major axis is 2 times a. Just tying that all together. And then also on the major axis, these 2 points that are already drawn in, those are the foci. Again, that's plural for focus. So I'm going to label the leftmost one first. So this is a focus. That leftmost focus has the following coordinates. The x-coordinate is h minus c, bless you. The y-coordinate is k. And then the rightmost focus has x-coordinate h plus c and y-coordinate k. So C doesn't appear in the standard form at all. However, there is an equation that relates A, B, and C. So if you're given either of the two foci for an ellipse, you can use that focus to find your C value, which then can help you find A or B if you need to. So the distance from the center to a focus is a distance of C. We'll talk about that as we go through examples as well. So that's the major axis. So then the minor axis for horizontal ellipse has endpoints again on the ellipse, but it's the vertical axis here. I'm going to highlight in green. And the minor axis has a length of 2 times b units. So that can be used to help you find the b value if you knew the length of that segment. And the endpoints of the minor axis are called the covertices. Again, plural for covertex. I'm going to label the top one first. So this is a covertex. And the top one would have the following coordinates. The x-coordinate is h, and the y-coordinate is k plus b. So from the center, the distance from the center to a covertex is b. So if you go up b, that's why the y value is k plus b. So then the covertex, or the bottom covertex, has the x-coordinate h and the y-coordinate is k minus b. So I had to kind of squeeze that in the way I wrote these out here. So both have x-coordinate h, top one, y-coordinate is k plus b, bottom one, y-coordinate is k minus b. So it's a distance of b from the center. That's why the minor axis is 2 times b units long. And that's all we need to label. The only other thing I want you to add in, and this formula actually applies to both, whether it's horizontal or vertical, is the relationship between A, B, and C. So C squared is equal to A squared minus B squared. So it's not the Pythagorean theorem. It's not A squared plus B squared equals C squared. C squared is A squared minus B squared. So for example, if you know A and you know C, you need to know B for your equation. You could use this formula to find B. Okay, we'll fill in the vertical because all the characteristics are the same. Formulas are different. Questions, though, on what something says up here, just make sure you have it filled in correctly. Okay. Then I'll move this, so then we're going to fill in, this one is the vertical. And for this standard form, I actually want to show this just so you can compare it to this one. So this is how the standard forms are different. For a vertical ellipse, this is the standard form. It's still x minus h quantity squared over, but now the x minus h quantity squared is over b squared, plus the y minus k quantity squared is over a squared, still equal to 1. Okay, so the difference between the two, what I want you to notice, between A, B, and C, A should always be the largest value. So if it's a horizontal ellipse, since the x-axis is horizontal, the largest value a squared is underneath the x. If it's vertical, the y-axis is vertical, that's why a squared is underneath the y. So the largest value is underneath the axis, that's the major axis, if you want to think of it that way. We'll label what's on the major axis, but I want to label the center first. Center is still HK. And now what I wrote up here for the major and the minor axis, the lengths of those two axes, that's the same down here. It's just now your major axis is vertical. So if you want to rewrite major axis again down here, you can. You don't have to. It is the same from up here. I'm highlighting it in the same color, so I still know that's pink. It's still 2A units long. The endpoints of that major axis are still the vertices. So I'm going to label the top vertex first. So this is a vertex, not a co-vertex, but a vertex. And it has the following coordinates. The x-coordinate is h. The y-coordinate is k plus a. The top vertex, x-coordinate is h, y-coordinate is k plus a. So the bottom vertex, x-coordinate is h, y-coordinate is k minus a. And then the two foci are also on that major axis. I'll label the top focus first. So the top focus has the following coordinates. X-coordinate is h, y-coordinate is k plus c. It's again from the center to a focus, that's a distance of c. And then the bottom focus, x-coordinate is h, y-coordinate is k minus c. And then that's all for the major axis. The minor axis is then the horizontal axis. Still has endpoints on the ellipse, and the endpoints are the co-vertices. So again, I don't have to write, you can, but you don't have to write minor axis as 2B units. Again, it is the same from above. I'm going to label the leftmost co-vertex first. So this is a co-vertex on the left. The x-coordinate is h minus b. The y-coordinate is k. And then the right co-vertex has the x-coordinate h plus b, y-coordinate k. And then again, the relationship between A, B, and C, that C squared equals A squared minus B squared, applies to vertical ellipses as well. And one thing I also want you to realize is when you have the equation of an ellipse, these two terms could be switched around because it is a sum of those two terms. These could be switched. So what you have to pay attention to, again, the larger value, if it's underneath the x, it's a horizontal ellipse, and if the larger value is underneath the y, it's a vertical ellipse. So in case they are switched, if they write the y term first, you're paying attention to what value is underneath to know what is a, what is b, or to find a squared and b squared to then find a and b. That'll come in more tomorrow when we're graphing, when we're given the equation. Today we're writing them ourselves. So you'll probably write the x first, just so you know the difference. Any questions on what any of this says? Otherwise, we'll get into the examples for today. Okay, and you're using these formulas to write equations of ellipses. So, if we look at example 1, and I really want you to focus on, you should be using the information you're given to write the equation. So I didn't see a lot of this, and I know I'm not passing your homework quizzes back yet because some need to take it. But what I saw on the last question of the homework quiz, and I saw this a little bit when I went through it in class, is say you were given the directrix, I had people using the focus to write their equation. So only use the formulas for what you're given. Don't try to guess what something else is. So if we look at example 1, we're writing an equation for the ellipse that is on this graph. First of all, looking at the graph, we should be able to tell that this is a vertical ellipse. So your first step is to determine if the ellipse is horizontal or vertical, so you know which standard form to use. So if it's a vertical ellipse, we're using the following standard form. So the a squared is underneath the y, b squared is underneath the x. And we need to find h, k, a, and b in order to write this equation in standard form from what we're given. It is often easiest if you find your center first. Okay, so I'm just going to put first step is you want to be able to find the center. And you might be able to find it just by looking at this picture. What would the center be? 0, 0, yep. Other ways you could find the center. Remember, I will be giving you distance and midpoint formulas. So the center is always the midpoint of the vertices. It's the midpoint of the foci. It's the midpoint of the covertices. Okay, so you could use a midpoint formula if you don't have a diagram where you can more easily tell where the center is. But center here is 0, 0, so that's our h and our k. And we can fill those in. Next, we need to find a and b. So in order to find a, you would have to be given, if you look at the formulas you have on your graphic organizer, to find a, you would have to be given the vertices or the length of the major axis. So because we know the vertices, those are 0, 5 and 0, negative 5, we can find a using the vertices. And I'm going to make a note on here, one of the easier ways to find a. So if we know the center is 0, 0, just because this part wasn't labeled on the graphic organizer, make a note that a is the distance from the center to a vertex. Okay, so if you know the center and then you know one of the vertices, in this case we know both, you can just find the distance from the center to a vertex. That is your a value. And that could be used by actually using distance formula between the 2 points, or if you have a graph, just by kind of counting the units. So in this case, what would the value of a be? What would the distance from the center to a vertex be? 5, yes. I'm going to label that on here. So from the vertex to the center, that is A, and that's 5 units. Now, that's not the only way to find A. So as you're working through examples, you might find other ways or brainstorm other ways that you can find A. Using the formulas you have on your sheet, there's other ways you can find A. The next step, so we have HK, we have A, we would need to know B. There's actually 2 different ways to find B. I want to show you both. So one of them, just based on the actual graph we're given, one of them is an easier way to find B. But I want to show you another way just because the way I'm going to show you first doesn't always work. So notice on this graph, they're giving you the ordered pairs for the vertices, and then they're actually labeling the ordered pairs for the foci. They do have points where the co-vertices are, and even though these points aren't labeled, you can easily tell what the point is. So we could say this is the point here of -3, 0, and this is the point 3, 0. So if you are given the points of the vertices to find B, all you would need to find B is the distance from the center to a co-vertex. So just like we found A by finding the distance from the center to a vertex, the center to a co-vertex is your value of B. So what would the value of B be for this ellipse? 3. Okay, now let's say we don't know for sure that these are the points. I guess we could even reason now we don't know for sure those are the points. We are given the actual coordinates for the foci. Here's another way to find B. Another way to find it is to use that formula you wrote on your sheet. Use the formula c squared equals a squared minus b squared. Because we already found A. If you're given the foci, you should be able to find C, and then you can use this formula to find B. So to use this formula, we've already said that A is 5. C is the distance from the center to a focus. What would the distance from the center to a focus be? The center to a focus is C, so what would the distance C be? 4. Okay, so I could substitute these 2 values into this formula to find B. So I would have 4 squared is 16 equals A squared is 5 squared, that's 25, minus B squared. And if I solve for B, I would have to subtract 25 from each side. 16 minus 25 is -9, and that would equal -b squared. So if both sides are negative, I can divide or multiply them both by -1, so b squared is actually +9. B has to be a positive number, so b would be +3. So that's another way you can find your B value if you're not easily able to count the distance. Okay, but once you have H, K, A, and B, you have everything you need to then substitute into your formula to write your equation. So this ellipse would be, since H and K are both 0, you don't have to write the zeros in. You can if you'd like. But rather than writing x minus 0 squared, I could just write x squared over b squared is 3 squared, which is 9, plus, again, rather than writing y minus 0 squared, I can just write y squared over a squared is 25, and that equals 1. So that's the equation of that ellipse. Okay, any questions on that example? Okay. Then example 2. So all of these examples, you're given different pieces of information. I just wanted to give you some different examples here. Example 2 says write an equation for the ellipse with vertices at -6, -2, and 4, -2, and co-vertices at -1, -4, and -1, 0. So this one doesn't give you a graph, it just gives you the ordered pairs. Just like we did with parabolas, I would recommend you actually plot these points so you can picture what the ellipse looks like. You can picture, is it going to be longer the horizontal way or is it going to be longer the vertical way, so you know which standard form to use. So I'm going to sketch these points. And I usually put by the points, like I sketched -6, -2, I'm going to put a V by it to know that, or to remember that's a vertex. And then the same with 4, -2, that's a vertex. And then co-vertices are -1, -4. I usually put CV by those for co-vertex. And then -1, 0. And when I have my 4 points plotted, I know that the vertices and co-vertices are actually on the ellipse, so I can draw an ellipse through those 4 points. Not that you'd have to actually draw the ellipse, you just want to know where the points are so you can kind of reason through things. After sketching that out, would you say this ellipse is horizontal or vertical? Horizontal. It's definitely longer. There's a greater distance between the vertices than there is between the co-vertices. So we have a horizontal ellipse. That means I'm going to write down the standard form. If it's horizontal, the a squared is underneath the x. Okay, and again, H, K, A, and B are the 4 things you need to find. It's easiest if you first find your center. Okay, center, remember as I said, the center is the midpoint of the vertices and the co-vertices. The other one, the graph we were given, it was a little easier to see that the center was 0, 0. I would actually use midpoint formula to make sure you're getting the right coordinates. You can either use the 2 vertices or the 2 co-vertices. So I'm going to just put here center, make a note, midpoint of vertices slash co-vertices. Midpoint formula I am giving you. Maybe I'll write it on the board here. So you remember it now. So remember it's x sub 1 plus x sub 2 all divided by 2 for the x coordinate, y sub 1 plus y sub 2 all divided by 2 for the y coordinate. So just make sure your 2 points are both vertices or they're both co-vertices. I'm going to use the 2 vertices. So for x, I'd have -6 plus 4 all divided by 2. Y, I would have -2 plus -2 all divided by 2. So my x coordinate is -2 divided by 2, so -1. My y coordinate will be -4 divided by 2, so -2, which makes sense. My center should be on the same line that my vertices are on. So that's my h and k, -1, -2. I'm actually just going to add that to my drawing for my center. And then here, because we actually know the coordinates for the vertices and the co-vertices, we don't need to deal with C at all. We can just find A and B. So to find A, Maybe I'll actually show you a different way to find A for this one. To find A, the way we found A in the first one was A is still the distance from the center to a vertex. Okay, so you could either use distance formula, you could just count the units on your sketch to find A. Based on how some people draw it, just counting it out sometimes gets them the wrong A value. So another way to find A is I know that -6, -2 was my leftmost vertex. If I look at my graphic organizer that has a formula, the x-coordinate is h minus a, the y-coordinate is k. How that's helpful, though, is I can set up an equation with the x-coordinate and say to find a, I know h minus a equals -6. I could have also done this for the rightmost vertex. That x-coordinate has h plus a, and the y-coordinate is k. So I could have also set up a similar equation, h plus a is 4. So you just have to know which vertex you're using based on your diagram. But now I can solve this equation for a because I know h is -1. So -1 minus a equals -6. So add 1 to each side. So -a equals -5. Divide both by -1, so a is 5. Your a and your b values should always be positive because they are distances from the center to a vertex or covertex. So your a and your b should always be positive. So a is 5. Questions on how I found a? Okay, now B, same thing. B, in the previous example, I told you B is the distance from the center to a covertex. I could certainly find the distance between the center and a covertex either using distance formula or just by counting the units on my graph or using formulas. So I know -1, -4, that was my bottom covertex. And my bottom covertex has a formula off of my graphic organizer. X-coordinate is h, y-coordinate is k minus b. And then the -1, 0, that x-coordinate is h, the 0 is k plus b. So I could set up two different equations. I'll just use this one. So I can set up the equation that k minus b is equal to -4. I could also set up that k plus b is equal to 0. And then I can solve this for b because I know k. K is -2. -2 minus b is equal to -4. Add 2 to both sides, so -b is equal to -2. Divide each side by -1, b is 2. Okay, so I'm just trying to show you some different ways that you can find the values you need. There's not just one way to do it. You kind of have to go through the practice and problem solve and figure out what you need to do to find the values you need. So now that I have h, k, a, and b, I can fill them into my standard form. So I have, since h is -1, x minus -1 is going to be x plus 1. So I have x plus 1 quantity squared over a squared is 5 squared, which is 25, plus y minus k. K is -2, so that'll be y plus 2 quantity squared, over b squared is 2 squared, which is 4, and that's equal to 1. Bless you. Any questions on that one? Okay, last one. This one's a little different. I just want to talk about this quickly, the way it's set up, or if you've worked ahead and you have an answer, just double check that what you have is right. But it says a listener standing in an elliptical room 150 feet wide and 320 feet long When a speaker stands at one focus and whispers, the best place for the listener to stand is at the other focus. Write an equation to model this ellipse, assuming the major axis is horizontal and the center is at the origin. Okay, so if I were to sketch this out, it's already telling us the major axis is horizontal, so I know my ellipse is horizontal, and it has a center at the origin. So I already know HK, that's 0, 0. I'm going to write down the standard form for the horizontal ellipse. So the a squared is underneath the x. So the only thing we have to find here is a and b. And this just gives us different information. I know the elliptical room is 150 feet wide, 320 feet long. And since the major axis is longer, I know it's 320 feet this way, and then 150 feet this way. Okay, so what are the 150 and the 320? What information are they really giving us? Or how are we going to find A and B? Okay, so they're giving us, this is the length of the major axis, which is 2 times A units long. So I know that 2 times A is 320. If I divide by 2, that means A is 160. The 150 is the minor axis, and that's 2 times B units long. So I know that 2B is equal to 150. If I divide by 2, that makes B equal to 75. Okay, so sometimes you are given the actual lengths of those segments, and if you know the lengths, you just divide it by 2 to find your A or your B. Okay, then I'm ready to substitute everything in. So again, since HK are 0, I can just write the x minus h squared as x squared, and this is y squared. So I have x squared over 160 squared is 25,600 plus y squared over 75 squared is 5,625, and it's equal to 1. Okay, so problem solving with what you're given. There was an example where you were given vertices and foci, then vertices and covertices, and the major and minor axis.